routing algorithms. What is routing? Routing is the forwarding of a packet in a network so that it reaches its intended destination. It is the responsibility of the network layer, which is the third layer in the OSI model. And the main goals of routing algorithm are correctness, that means it should be done correctly. Simplicity, that is it should be done in simple manner. Robustness, that is it should have the ability to withstand the system overhears. Stability, that means it should be stable under all circumstances. And it should be optimal in terms of throughput and minimizing the packet delays. There are two types of routing algorithms, adaptive and non-adaptive. Adaptive is also known as dynamic because it changes routes dynamically after every delta t seconds, or either when load changes or when topology changes. It gathers information at runtime either locally from adjacent routers or from all other routers. And the shortest path in clearing out examples that is in our syllabus. Talking about non-adaptive, it is also known as static because the choice of route is computed in advance and is made offline and downloaded to the routers when the network is booted. Talking about the shortest path, it finds the shortest path between a given pair of routers. And the cost of link may be a function of either distance, bandwidth, average traffic, communication cost, or delay. For example, Dijkstra's algorithm. This is an example. I solved this question using the Dijkstra's algorithm. A is the source and the D is the destination. This is the source and this is the destination. And our purpose is to find the shortest path. That is the path with the least cost. And by applying the Dijkstra's algorithm, I have found the shortest path. We will first start with the source and then we will look for the nodes that are reachable from this point. For example, here we can reach B and G from A. So, and we write the cost. How much it costs us to go from A to B? It costs us 2. And this was 6. So I wrote this below the nodes. And then I locked that node which has the shortest path. Like A to B, it will cost less. So I travel A to B. And then I check from B. I can go to C or E. From here, I will check which one will cost less. From, say, if I go B to C, it will cost me 7 and this. So my total path would be A to B and B to C. So total cost would be 7 plus 2, which will be 9. And if I go from A to B and then B to E, then it will cost me 2 plus 2, 4. So this will be the shorter path. So this is why I will go from A to B and then B to E. Similarly, I will explore all these paths, all these nodes, and find the path which will cost me the least. This is the Dijkstra's algorithm for the shortest path routing algorithm. Next we have threading. In this we that every incoming packet is sent out on every outgoing line except the one it arrived on. Like in this figure, as you can see, the packet that is arriving on A is sent to B as well as C. That means the incoming packet will be sent to every outgoing line. Every other outgoing line except the one it arrived on. For example, here we send it to B and C, and from B we send it to D, and from C we send it to D and E. And the problem with this algorithm, the disadvantage, is that multiple number of duplicate packets are generated at the source. For example, we send the same packet from B, and the D is also receiving the same packet from C. So we have duplicate packets at the destination. This is the disadvantage of this algorithm. Then how do we stop duplication? We have 3 methods, which is the hop counter, sequence number on packet, and selective clearing. First, talking about hop counter, we use a hop counter. We assign a value to